A model can generally be thought of as having parameters that one wants to vary and some standard analyses that are wanted for each variation. The common types of parameters that users wish to vary include material properties, position of parts, orientation of parts and sizes, or distortion of part shapes. This is the same solved quick start model as in part 1 of the Faraday tutorial video. From the menu bar, select Solution, define Parametrics, Parametric Setup. The Parametric Setup dialog will open. Click the Create button in the lower left corner of the dialog. The Parameter Editor dialog will open. The default parameter type, Geometry Displacement, is what we will be using, so we will not change this. However, you may wish to browse the list to see the various parameters that can be set up. Edit the name, steps, and target point as shown here. Click the Select Geometry button. The dialog will close while you select the geometry. Either use Volume or Object Selection to select the disk. When the disk highlights green, right-click to End Selection. The dialog will reappear, and the disk geometry is highlighted green, indicating the parameter will apply to. Click Apply Create. The Parametric Setup dialog will appear again, but with your defined parameter now in the Parameters Defined list. The geometry corresponding to the selected parameter, the only one in this case, is highlighted green. To visually confirm what the setup parameter will do, select Validate button on Parametric Setup dialog box. To visualize the total parametric setup, click the 2 arrows highlighted below to toggle the display to the fully expanded dialog. The defined outputs don't appear under post-processing here. That list is for the temporary outputs that can be obtained from the Analysis menu. Open the Define Outputs dialog and check the box to save the model display data with each plotting step. Save this model, and from the Solution menu bar, select Run Parametrics and perform parametric analysis. A dialog will open prompting you for a database name to save the results in. It is recommended to modify the name to Faraday Quick Start Sample 2 Results. The solver will now iterate through all the requested parametric variations. When it is done, the final parametric table will appear. Click the Graph Results button. Set the Graph Results dialog as shown and click on Graph Results. A graph will appear showing the force versus the parametric step number. Click the Close button for all open dialog boxes. To analyze the defined outputs, select Analysis Output Manager from the menu bar in the pop-up dialog and set the animation slider to the fast end. Click the Animate button. Amperes will cycle through displaying your plots. Press the ESC button on your keyboard to stop the animation. When you have settings you like for animation, you can use the Save Animation button to make a video file. To view plots from individual analysis, set the step number, then click the Show Step button. Scripting via the API is the other major way of automating the use of integrated software. Scripting takes more setup time than parametrics, but offers much more power. While parametrics are restricted to studying systematic variation of existing model parameters, scripting offers many more possibilities. To run a script for the first time on your computer, some extra setup will need to be done. Close Faraday and using Windows Explorer navigate to the folder when Faraday is installed. Right-click on the file is.exe. In the pop-up menu, click Run as Administrator. Faraday will open in a special mode that sets up the Windows registry for external scripting control. Close Faraday. The scripting examples are provided in a zipped folder placed in your document folders. Double-click on the API Samples folder. Inside this folder is a zip file, also named API Samples. Right-click on the API Samples zip file and extract all. Navigate into the API samples folder. Double-click the Excel folder to open it and double-click the file Ampere's Faraday Halbach Wiggler sample to open it. You will probably be prompted with a warning message about the macro in the spreadsheet. Click the Enable Content button. Now start Faraday normally and click the Run button on the Excel sheet. While the macro runs, both Faraday and Excel will be locked. The macro will create a wiggler with 9 magnets on each side. When the macro has been completed, the spreadsheet will show a data table and plot of the Z component of the B field along the line from point 0, -12, 0 to point 0, 12, 0. This example shows a very quick, limited use of scripting. Similar targeted tools can be developed as scripts, but much more ambitious custom design tools, even involving the creation of the model, can be created.